Welcome back to the channel, guys, and we are working on a deep learning project called brain tumor detection and classification with web interface. As you can see, there is a cute little panda in the background. Let's come on to the project. I am working on a brain tumor detection and classification with web interface project where I have already done the deep learning code, but I haven't implemented the web interface. I will be implementing the web interface after this video. I mean the next videos. I will implementing the backend, and after that I will be implementing the front end as well. So I will just explain you the code, and I will have to work on this code as well because the output is not giving correctly. I have importance of important libraries NumPy for like converting the image into NumPy array, and also we are going to use a NumPy function called np.argmax, which gives the most predicted value, and we are going to use CV2, that is OpenCV, for converting the image into size where both are similar, like it's image resizing into a similar part. Many images won't have similar shape. Deep learning projects TensorFlow accepts only images which are regular in shape. And matplotlib and TQDM, I'll say you what is this function, and in OS for some important libraries importing, and random for implementing random numbers, random images. We have implemented labels as glioma tumor, no tumor, meningioma tumor, pituitary tumor. Three types of tumor, it's gonna predict which type of tumor it is, and if there is no tumor, it's gonna return no tumor. So the labels are these four, and we are working on a dataset called training and testing. It has three types of tumor like glioma tumor, meningioma tumor, and pituitary tumor. Also, it has no tumor. This is an image which contains no tumor. You can see that. This is an image which doesn't contain any tumor, right? Pituitary tumor. Here, at the glance, there will be a present tumor. That is a pituitary tumor. I can show you the images as well. In the another images, you can see that there is a tumor in this region. Maybe it is not visible correctly. Yeah, this is a tumor. In these glands, between these two glands, there is a tumor. That is pituitary. I won't go into detail because I'm not a biology student, guys. I'm an engineering student, so I will be just implementing the model. And this is a training data set which contains glioma tumor, and same, it is the same thing. And the model I have said is f0.keras. I will be deleting this model because I have to implement the new model, guys. Coming back to the code, I will be just running this code. I have the base Python model which is 3.1 to 1.4, which is a very faster model, and this code is running. And let's run this as well, labels. And we have taken two list X-train and Y-train, and we'll be storing image size will be 150 cross 150, guys. I'm just doing is what in the training data set, I am resizing the image in X-train and Y-train. X-train is basically the image, and Y-train have the label of that image. If image is glioma tumor, then it will be labeled with the image. Like this is an image, this is a X-train, and there will be a label called Y-train, which is a will be predicting glioma tumor. This is what the code does. I'm using CV2 to read the folder path, and then I'm gonna resize the image size and image size, that is 150 cross 150, and I'm gonna adding that image to until it won't complete, right? TQDM is basic. When we run the code, let me show you. This is the TQDM function. What it does is it creates a beautiful UI which shows how the images are loading into the data set of X train and Y train. So let's complete this function, and this gonna take some time as it took 1 minute to run this code after loading these images with the labels as well. So this is nothing but doing very simple, guys. It is labeling the images as, because I have mentioned labels, and it's gonna take glioma tumor, and it will gonna add after the label changes the image as well, it changes. Labeling is important, guys, to train the model very well. The next part is I will be joining the training part. I will be converting that X train, that image, into a NumPy array, the mp.array, because image to get the output which has a more value, then you have to use a NumPy array. It's running beautifully. And let's plot some images in the testing or training model. So I will be using figure.axis and I will be plotting using subplots. The figure size will be 14 cross 14 guys. And I have already run this code, but font weight you can set bold. I have set it bold, and x-axis let's set 7.8, and it's gonna show while true until we continue. So yeah, J will be incremented when one image is showed. I mean, we are implementing 4 images, which is of glioma tumor, meningioma tumor, no tumor, and pituitary tumor. Yeah, let's turn this. You can see that this is a glioma tumor, which is basically inside of the tumor. And no tumor, there is no tumor here. Meningioma tumor basically lies in the sides of the brain, and pituitary, as you know, this is a tumor here. And let's shuffle this, cause if we won't shuffle, then the model when we will gonna train, then it won't learn, it will just by heart the things like we do. Let's shuffle this guys. Shuffling is important because the model must learn, not it should not by heart the things. It should learn from unknown things. So we have to shuffle the images. So I am training X train and Y train is now shuffled, and after this shuffle function we are using from sklearn. And let's see the shape of the model. And Y train, let's remove this. X train shape is 150 cross 150, which is very good. And 3 is basically RGB, red, blue, green. The shape of lies in the RGB only. RGB colors only. Yeah. So there are total of 3264 images of all the types of tumor with no tumor as well. I won't be repeating no tumor. I will be repeating only all the types of tumor. So yeah, Xtrain has 3264 models, but we have to use also testing data set from this model. So I will be using Xtrain, Xtest, Ytrain, Ytest, and we're gonna use train test split function from sklearn model.selection. And the test size will be 1%, which is 0.1, which is 10% of 100, which is 90% gonna be training side and 10% gonna be testing. And the random state we have to implement is 101 because randomly it need to understand what we are going to do. This is what we have done, and we're gonna add the labels for Ytrain as. Labels are nothing but telling that you have this type of tumor. And let's plot the image and understand how we are using this thing. So the same thing, figure size gonna 20 cross 20. Same thing I have implemented here, but we are gonna use it this code, and you can see that sample image from each level. You can write it in your own rights. Sample image from each level I can write related to the logic we need to write, and size I have kept at 18. And this is what this is for this guys. What is happening in this code is the difference between only in this code and that code is we have mentioned glioma tumor here, no tumor here, meningioma tumor here, pituitary tumor here. But deep learning projects won't understand this English alphabet. So what we are going to do is, so we have to label it as 1, 2, 3, 4. So glioma tumor will be 1, no tumor will be 2, this will be 3, this will be 4. So what I did is, in this function, I have appended this value and I have labeled index as I. I is nothing but 1, 2, 3, 4. And now I'm going to plot this. You can see that label 0 is set for glioma tumor, label 1 set for no tumor, label 2 set for meningioma tumor, which is at the side of the brain. And label 3 is a pituitary tumor, which is inside these two parts of the brain. Now we load the model, and we are using efficient net B0 model, which is already pre-trained model on millions of images. Let's understand where efficient net B0 train on how many data, a million images. So this is the best model. I can use B1 as well. B2 is also there. B3 is also there, but I'm gonna use B0 because I'm just training in a normal thousands of images. So yeah, the last layer will be given by us, and the rest of the layers in the deep learning model will be created by the efficient model. I have imported TensorFlow as here, and we have, for processing we have used image data generator. From the applications part, we are importing the efficient net B0. You can also import your own different model as well, guys. Let me show you. Keras dot applications. We're gonna import. There are a lot of model, guys. Efficient net V2, B0, B4, B2, many models, but I'm gonna use B0, B0. Yes, this model. I'm gonna comment this out, and I'm gonna run this. And for white train, I'm gonna use a categorical function for training the model. And now let's create a model by using FNet model. FNet model is nothing but efficient net B0 model where weight's gonna be ImageNet. Include top is nothing but false. Why? Because false means we at the last layer we're gonna create our own 4 layers, which is of this 1, 2, 3, 4. So that is why I kept the last layer as false. Okay. The next step is simple guys. I have implemented the last layer global average pooling layer, which is a 2D layer, and dropout I have kept at 0.5. If the model is not learning correctly, then it will decrement to 0.5%, and the dense layer is 4. As I said, there are 4 types of things in our testing on training model. So that 4 is for that model, and activation I have used softmax. Softmax is just is converts the values into a categorical value which is of between 0 to 1 and predicts the outcome which is having more prediction value. Model is called a model. So yeah, I just run this model. Model gonna save in the model function. Now I'm gonna compile the model, and loss I have used categorical cross entropy. Categorical because we are using categorical values, and the optimizer I'm gonna use is Adam. If you are not aware of this, just just write Adam optimizer in TensorFlow. Just you go through this TensorFlow model which is created by Google. Optimizer that implements this is a model. Adam optimizer is the gradient descent method that is based on adaptive estimation of first order, second order movements. And matrices is accuracy. We are gonna train our model based on accuracies. And for early callbacks, I'm gonna use early stopping. If the model is not learning, then it's gonna stop and reduce its learning rate to 0.5 maybe. Yeah. And we have used this reduce on plateau and model checkpoint. Let's run this, and it's gonna compile the model. So yeah, what these 3 functions does is these 3 functions are very important. This tensor board shows low accuracy graphs, like where is VR model not learning. For checkpoint, we are gonna save the model as fnet.keras. Let's create a model function, guys. Models already exist. There's already model function which exists here. Let's save it here casually. fnet.keras, and monitor is based on a validation accuracy. If the accuracy is good, then the new model will be saved as fnet.keras, and this fnet.keras will be overridden many times when the validation accuracy improves. Yeah, let's run this. And this is reduce R on plateau is used. Validation accuracy doesn't improve for 2 epochs, then it's reduced its learning rate by 30%. After that, we are using model.fit. We are going to fit explain y train, and split will be 0.1, which is 10%, and epoch is 2, verbose is 1, batch size is 32. Not let's keep the epoch size 10, and let's run the model. It's going to take a lot of time and a lot of CPU. GPU, run the model. Guys, it's gonna take a little bit time, like around 10 to 15 minutes until the model is ready. I'll just show you one epoch and I will skip the rest of the part. Guys, as you can see that we have trained our model and we have completed 10 epochs and successfully the model is learning and the accuracy is 97%, 98%, and the validation accuracy is also good, that is 91%, and the model is loaded here, that is fnet.keras model. I have saved the model there. The last at the 10 epoch, the model's accuracy is 99%, which is very, very good to improve, and the validation accuracy is also 98, which is perfect. And we have saved the model here. This is the best model which you cannot see because it is a binary file which is of zeros and ones. And what we have to do now is the prediction is going to predict using an argmax function. Let me tell you what is an argmax function. Argmax takes the maximum value upon all the values in the data. So if the model predicts 0.2 for 0. Not 0.2, that's 0.2 for pituitary and 0.8977 for no tumor and 0.001 for meningioma. Then it's gonna use 0.77 for no tumor and it's gonna predict it is of no tumor. We use the insert function which I have to remove it. Yeah. So y-test is already in correct format, guys, and we have used a new function called y-test new, which is saved with y-test function. And let's run this. This gonna save the y-test model, y-test new model, and there are total level. So yeah, it's running. What is happening here is 0 is for glioma tumor, 1 is for no tumor, 2 is for meningioma tumor, pituitary tumor is for 3. And it's gonna predict like which has the more accuracy, that is predicted as 1, no tumor. Like I have already said here. And let's generate the classification report of the model, like where are we lacking or what is our actual accuracy and how it is going. You can also create this using matplotlib, but we are not going to this because our aim is to build a model. You can see that the recall is 0.96, F1 score is 83, support is it's all good. Let's import confusion matrix and see whether this is a heat map of the confusion matrix, which I have trained at the starting, but it was giving a wrong prediction. For glioma tumor, it was giving 85 correct predictions for glioma tumor, but for no tumor and meningioma tumor, it was giving me 51, which was very wrong. Let's run this, hope it's going to predict correctly. Color green is not defined. Okay, we haven't defined color green. Okay. What I understood is we haven't defined the color green. So we have to use from so yeah, this is the color green is not defined. So what we are gonna do is we're gonna import from Tbon, import, and let's import Cbon directly. Import Tbon as SNS and let's define color. It is a predefined color and I will be showing you these colors I have taken. Yes. So this is a color dark, color green, color red. This is the values in the color. You can search it on Google and find the colors directly. So yeah, this is a black, green, and red color. Let's not print this. I have defined the color and I have used the colors. Yeah, let's run this and hope our model confusion matrix is working fine. Please. Okay. Okay. I don't know what's happening here. Model is not learning. Okay, let's run this and let's display. Let's paste the upload image. I'll be using a brain tumor detection. There's a BTC for testing. I got please predict correctly. Okay. Please predict correctly. Okay. Oh yeah, after the classification report, we're not going to generate the heat map as we are building the model. So yeah, this is a prediction image where we're going to upload the image, and uploader will be used in the form file info, and this is the color which is of array. The image must be of array, and RGB is the color which we are going to use. And again, we are reshaping the image because when we are going to predict the image, if the image is of different size, it won't predict because we have trained a model in 150 cross 150 and RGB, and it's gonna make it resize and it's gonna predict also how it's gonna predict based on the argmax function. As I've already said, it's gonna use the most maximum value, maximum predicted value. Then if the p is equal to 0, that means it is a glioma tumor. If it is 1, there is no tumor. If it is 2, it is a meningioma, else pituitary. So yeah, let's load the model here and let's take some examples. Testing. This is a testing data set which model doesn't have. Let's paste the pituitary tumor. This is a model with pituitary tumor. I'll just paste this. I'll just predict. It says pituitary tumor. Okay, let's run this again. Let's run this again. Let's paste this. I'll be pasting meningioma tumor. This is a meningioma tumor. It is at the side. Now let's paste this and let's predict. And it's correctly predicting it is meningioma tumor. Let's paste some other things as well. There is no tumor. I'll predict for this image and I'll just predict. So there is no tumor. Beautiful. This is what it is. I don't need to get this thing. I'll just delete this. I have pasted the meningioma. Yeah, the model is working fine. And let's check out some Google images and paste it whether it is gonna run full or not. I'll just use some Google images of. Let's take a MRI image from directly Google. So yeah, this is the images of glioma tumor. What I will do is I'll just copy the image. I'll just take a simple. This is a MRI image of glioma tumor. I'll just save this image and see whether this is running fine or not. Just go to my BTC. I'll just save this image here. MRI. Let's run this. Model is good. Download it. And let's upload a new image. If it predicts glioma tumor, then the model is working absolutely fine. If it isn't, we have to train our model. Let's hope it is a glioma tumor. Oh, super. It's predicting correctly. So yeah, let's check for the pituitary tumor MRI image and see whether it's looking fine or not. I'll just take this image and I'll just save this image as. I'll be saving this image and let's click on. Let's upload the pituitary image which I have recently saved and let's click on predict. I hope there is a pituitary tumor in the model prediction. Yes, it is. So yeah, the model is working fine. And let's build the UI. Okay guys, I will be building my UI in the later videos. This is how I have built the model. Till here, we have completed our model building. Let's save this in GitHub. And see what is happening. The model is saved. Let's directly push the code into the GitHub. Okay. The GitHub code is pushed and we are done with this for today's video. We will be completing our backend and frontend as well in the next coming videos. Thank you for watching. Do subscribe.